Hi, my name is James Coble. Welcome to this Capstone project video presentation. The title of this project is Enhanced Correlation Between Real-Time Stock Performance Data Graphs and a Real-Time AI Machine Learning Generated Stock Sentiment Data Graph. As a capstone project in the domain of informatics, this project has two components: an implementation component and a research component. The project creates and implements a technological innovation, specifically a control in a user interface where the user interface displays multiple stock graphs within a single chart, and all graphs share a single x-axis scale. The implemented control provides for an improved user experience. The software implementation component is a web application based on the Flask framework, where the application consumes JSON response data from two separate APIs. The first API returns stock performance data, and the second API returns AI machine learning generated stock sentiment data. The time series data returned in the API responses is processed using Python libraries to produce a stock price line chart graph, a stock volume bar graph, and a stock sentiment bar graph. Alright, a quick demonstration here of the web application. Again, it was created with the Flask framework. Produces a single page, a single UI. Just to go over it real quickly, we have the logo area here. These are message outputs, text outputs. If there's an error, currently it states an error because we don't have the required input into the stock symbol and also the GMT time for historical date. The control here sets the resolution. It can be set either 1 minute, 5 minute, 1 hour, or 1 day, and the testing was done on the 5-minute resolution, so we'll stick with that. Let's provide a GMT. This is a historical date time. 1330 is actually 9:30 New York time, US New York time. Put in a stock symbol, GME, we'll load it. It's going to hit two APIs, one for, it will pull candlestick data, and from that the stock trading price graph is created, and also the volume. On a 5-minute resolution, we have from 9:30 New York time until 12:25 New York time. The bottom graph here is the AI machine learning stock sentiment, and this is consumed from a separate API. Actually, Stockgeist is the API for the stock sentiment, and the stock performance, which is the price and volume, that is being pulled from FinHub. So just to quickly demonstrate the control here for adjusting time, quick demonstration would be, let's select 11:45. We have, looks like a volume of 5 negative. The sentiments, red is negative, green is positive. There's also a neutral value available, but I did not include it in the graph. I'm going to zoom out so we can see how they line up. And we can see that this negative sentiment currently, ends up at approximately here on the stock trading price. So to better increase the visual correlation between this negative sentiment and this drop in price, which is what we believe would be the corresponding stock performance data point, would be this negative dip in the price here. We're going to go ahead and adjust for let's say 30 minutes, and this will only shift the stock sentiment. We will refresh. When we refresh, it only hits the this single API here, the StockGeist API, and we see it did shift over. It is now, let's zoom in. It is now shifted over to 11:15 Eastern US time. And let's zoom back out and see. We can see now that it has shifted over, and it's now corresponding with this data point on the stock trading price. And we believe that this would be the corresponding data point. So the correlation is greatly improved when using this control for shifting the stock sentiment data points horizontally. And again, the x-axis scale, it's a single scale. It doesn't change until we go to say a different historical date time, of course. And that is the application. Thank you for watching. The software features a user interface control. The control is demonstrated in the demo video. A stock sentiment graph x-axis adjustment control is its name, which is central to this project's research component. This UI control can be set to change the horizontal position of stock sentiment graphs data points along the x-axis scale. With an optimal adjustment value applied to the control, a significant improvement in the visual correlation between corresponding data points on the stock performance graphs and the stock sentiment graph is observed. The research component is a research effort designed to test the efficacy of the featured UI control, where a single research question is presented. The research approach taken is that of empirical research using a quantitative research method. This approach allowed for quantitative data to be collected and then statistically analyzed. The research question is as follows. Does a UI control which provides adjustments to the timestamp property of an AI machine learning generated stock sentiment data set enhance the visual correlation between the data points of its resulting graph and the data points of stock performance data graphs, where the graphs are combined into a single chart? While conducting empirical research using a quantitative research method, empirical data was collected by observing the visual correlation between the data points on the stock sentiment graph and the data points on the stock performance graphs, as seen in the demo video. Data collection continued until 5 consecutive full trading days of data had been collected on 5 different U.S. stock symbols. An Excel workbook was created and a separate worksheet was created for recording observations for each U.S. stock symbol. The process of collecting data begins with setting the web application to a specific U.S. stock symbol. In these 2 figures, this again just as an example, and this is the same stock symbol that we had previously seen in the demo video. This is GME US stock symbol, which is GameStop. In the figure here on the left, you will see that the adjustment minutes is set to 0. We'll take this data point, stock sentiment data point, which is occurring at 11:45 a.m. Eastern Time, and we will look at the visual correlation between what we believe is the corresponding data point for the performance, stock performance data point, stock trading price actually. And we believe that that corresponding data point would be here. And as we know that there's a 30-minute offset between these data points, the data point of the stock price and the data point of the AI machine learning generated stock sentiment data point. And conversely, when we make the adjustment here for 30 minutes and we shift the stock sentiment data point by 30 minutes, and it's now occurring at 11:15 a.m. US Eastern Time, that it now aligns with the corresponding, what we believe to be the corresponding stock trading price data point, and the visual correlation is much improved. When we collected data, it was across 5 different symbols that we see here. We have AMZM, Amazon, GME, GameStop, and so forth, NVDA, Tesla. So looking again at the GME and the same data point, that's 11:45. So with 0 minutes of adjustment, we observed a 30-minute offset. And as we make adjustments, we see that the offset decreases down to 0 minutes of offset when we apply a 30-minute adjustment. So for each day of trading, we started our observations at 10 a.m., which is 30 minutes after the beginning of trading, and that's to allow for up to 30 minutes of adjustment. And then we continued through what would be 4:30 p.m., which is 30 minutes after the end of trading, and again to allow for 30 minutes of adjustment. You'll notice that there is the potential for 78 observations in one day of trading. However, where you see the red, where you see no data, that means that there was no, for example, in this area here, there was no stock sentiment data provided. So we continue through a full week. This is Monday, and we go all the way through to Friday. And we repeated the process across all 5 US stock symbols. And that was how data was collected for this research project. To analyze the resulting research data, 2 sample assuming equal variances t-tests were performed on each data set produced from an applied sentiment graph x-axis adjustment. where datasets with adjustment were compared to a dataset without an adjustment. The alpha value was set to 0.05 for each test. The mean value and two-tail p-value were observed for determining statistical significance. For each U.S. stock symbol and each trading day, Monday through Friday, the t-test which produced the optimal result, and we first looked at the mean. So the lowest mean would be the optimal result. So in this case, for example, negative 15 minutes, this particular adjustment produced the lowest mean when running the two samples assuming equal variances t-test, and the two samples would be 0 minutes of adjustment compared to an applied number of minutes adjustment. So again, in this case, 0 minutes compared to 15 minutes adjustment produced a mean of negative 1.25 minutes. That was the average offset. Now for this table, the optimal results were aggregated into the table, and for statistical significance, only data sets where observations of 30 or more were considered in the final results. So in this case, nothing from the Amazon was considered because the highest observation was 8 on Monday, October 7th. However, if we drop down to, say for example, GameStop, GME, best stock symbol, you can see that Monday, Tuesday, Wednesday, all three of these actually qualify to be considered for statistical significance. So looking at GameStop here on Monday, negative 25 minutes of adjustment. When that was applied, we were able to achieve less than 1.5 mean. On Tuesday, 0.7, Wednesday, 1.5, and so forth. So apart from the mean, we also considered the two-tail p-value, and with our t-test, an alpha value of 0.05 was used. So the statistical significance cutoff would be anything 0.05 or above that would be considered not statistically significant. However, we can see that all of our two-tail p-values are well below 0.05. And that is the data analysis. After analyzing the t-test results, it can be observed that by adjusting the AI machine learning generated stock sentiment graph along the x-axis scale, visual correlation between the data points of the stock sentiment graph and the data points of the stock performance graphs is significantly improved. Users' experience is shown to be enhanced, and the software implementation is supported. Limitations worth mentioning include the dependencies on the required APIs, and it is important to point out that all observations were subject to interpretation. Because of the limited scope of this research, future research could be conducted on data sets, for example, where visual correlation between pre-market stock sentiment data points are adjusted to match their corresponding stock performance data points at the opening of a trading day. During this video presentation, the two components of the overall project were demonstrated. The software implementation component produced a UI for displaying and controlling stock graphs, and the research component tested the UI control for its efficacy. Finally, the method of research was demonstrated along with the research results. Hi again. Thank you for watching this Capstone project video presentation.